Okay guys, so we started the coding with Matlab and the plotting commands, that's right. So I taught you too many things and now we're continuing with the subplot. Okay, so here we are. So subplot is this. So we have figure 1 subplot nm1, nm2 and nmk, that's right. K is n by m. So so suppose that, so what I mean? So I mean that n is the number of the rows, m is the number of the column. Okay, so you're gonna have fixed number of this. What is changing is this. So it means the first row, first column, second, first row, second column, and go on. Let me show you here, guys. Okay, so for this, I'm gonna show it here. Okay, by example, you understand what I'm talking about. So we are in the practice 20. So plot the following function through subplot command. So y1 is this as a blue line and y2 is this as a black line for this interval. Okay, so we have to define this. X is equal to from 0.05 until 5 semicolon, because I don't want to show it in the workspaces, right? So now I'm defining 1 underline 1 is sine of x plus cosine of x semicolon, because I don't want to show it in the workspace. What it is cosine of x and this, oops, okay, understand? So and cube, that's right, this is that we want to plot. So is this right? Obviously no. Why? Because x is vector. I told you several times you have to put dot cube. Okay, now I'm gonna say figure 1. Okay, now I want to have this, guys. Let me plot it here for you. I want to have this. I want that this plot, if this is the figure, I want to have one sub figure here, one sub figure here. So you have one rows like as matrix, 2 columns or as vector, that's right. So what you're gonna have, this is this. So you're gonna have subplots, okay, 1 and 2. So let me show it again here. So 1 and 2, this is number 1, this is number 2. Understand? So it's gonna be number 1. So what I'm plotting? I'm plotting plot x and y1. Okay, and it says as a blue line. So I'm gonna say blue. Understand? So here we go. And then subplot 1 and 2 and 2. Okay, look at here, guys. I'm in this, look at here, in this second one. That's right. So the take-home message is that these numbers 1, 2, 1, 2, you are not changing this, you are only changing the last ones. Okay, so plot, it says x and y2. Okay, and it says a black line. As I taught you, black line we are showing with the K. Here we go. And grid. Right? So let me run this. If I run this, we're gonna have this, right? So also I forgot to put the grid here, guys. Okay, because for each of them in subplot you have to, so you have the grids. Understand? So now you can assign different things. You can say x label. Okay, it is I'm gonna put in the LaTeX interpreter x. Here we go. Okay, and font and the font size is 20, and interpreter is a LaTeX. Here we go. Okay, and it's y. See, it's y. This is for subplot 1. It is y underline 1. This is very helpful here. Suppose that this is, I don't know, it's meter. Okay, y underline 1 and this. Okay, this is for subplot 1. So if I do this, oops, what happened here? Oh, this is a typo here, guys. Interpreter. I just want to copy paste here. Okay, okay. So And now, okay, so we're gonna get this. That's right. As I told you, it's a very fancy font. That's right. So it is Y1. This one. So you can do the for the second subplot as you did here. That's right. Suppose here we go. This is X again. This is Y2, and you get this, right? Y2. So this is subplot is very helpful kind of plotting. If you don't want to plot in the same figure and you want to have, suppose because when you're publishing the journals, because of the journals, they are being written as a 2 columns, so you have a limited space. So the subplot is a good command that you can fit your figures inside the text. So let me show what you're going to have. So file, save as, okay, save as, I'm going to save as subplot example, and I'm going to save as, always I'm emphasizing you have to save as fig, because then you can edit that, so as JPEG. So and now if you go to subplot JPEG, here we go. So it looks like this. It's very, very fancy with the fonts and so many things. But don't confuse yourself, because in one of them, this subplot, you can have several things. Look at here, guys. Don't think that you can only put one. So say Y3 is I don't know, sine of x square, again because x is vector. So here you can say plot this for me, and the x and the Y3, okay, and I don't know, blue and dashed, okay, understand? So, and you have to change it to I, because now you have 2I, that's right. Then you can add here, as I told you, what you can add legend, that's right. Legend is for, this is for Y1, okay, and say Y2, okay, and you can add interpreter as LaTeX, as I taught you. That's right. I'm going to show the results. Bear with me. So, and here we go. Understand? So, if you plot this, what happened? Y1 and Y3. Oh, I forgot this, guys. Right, legend. Okay, so see, I'm making it bigger, coming up. So you see that this is Y1 and Y3 is very fancy, this kind of. So in one plots, you can have n figures, you know what I mean? But this is not the point. So I made it the dashed, and it looks very. So I said it the Y M. Oh, why I changed that? So oh, this is bracket. I'm sorry, guys. So if you look at this, so everything is not good. So it says that this is for Y1 and Y3. This is Y2. So I mean that there is no limitation in subplots. Okay, please try this at home, because I want that you practice it. So I'm gonna do the second and the third. You have to do as homework at home. Okay, this one. Okay, this one. Y1 is this as a red dashed line, Y2 is this as a solid black line, Y2 is this, and Y4 is a solid black line for this line. So you're gonna have 4 subplots. That's right. So I'm gonna copy and paste here, because let me do it, because I wanted that you to see how I'm doing. Okay, here we go. So the interval is what? Interval is this. Interval is this, between -1 and the step is 0.01 and 1. Okay, so Y1, oops, Y1 is how much? Sine of x multiplied by cosine of x. Oh, cosine of x. So guys, okay, so are we done here? Are we done here, guys? I'm asking you. Answer the questions before I say the answer. No, because this is vector. I said dot multiplication, that's right. So let's see what happens, okay? If I run this, guys, I'm gonna get error message because it says, hey, you cannot simply multiply by this star, it is a vector. So you have to make it as this. Here, guys. Here we go. Now it's doing, okay? Be careful again, I'm emphasizing. So y2 is what? Cosine of x and root square of that, 0.5. And are we done? No, because this is a vector, that's right, 0.5, okay? And the y3 is how much? X square, okay? And y4 is how much? Is cosine of x, x to the power of, again, dot, so 1.2. Okay, just for practicing. Okay, so please do it at home. So now figure 1. So now you have 4 plots that you have to do it with the subplot. Okay, so what you're gonna do? So you're gonna have this figure, guys. You're gonna have 1, 2. I'm gonna do this 3 and 4. You can have also this 1, 2, 3, 4, but this is too wide, that's right. If you want to publish in a paper, journal paper or conference paper, you cannot handle it, so because it's going to be exceed the limit of the columns. So 2 by 2 is the best option. So your subplot must be like this. Subplot is 2 and 2, like matrix, 2 rows, 2 and 1, 2, 3, 4. This is gonna change this, right? It's recording. Yes. So we're gonna do this. Subplot 2, 2, 1 first. 2, 2, 1, and I'm gonna, guys, do this. I'm just copy and paste because for saving time. Okay, and here we go. And I taught you how to make it as a code. Okay, Control T, like a 3. Make it as 3. So, and because I want to have different, so this is gonna be go. And it says as red dashed. Okay, red dashed, you're gonna say it's an R red dashed. So this is gonna be y1. Oh, this is gonna be x, guys. And it's gonna be y1. That's right. We don't need legend because this is one plot in this figure. That's right. And here we go. So subplot. Let me copy and paste this here. And you have to do, after passing this course, you don't need to plot everything by hand. Be smart. So subplot 2, 2, and now I'm going to the second subplot. So it is gonna be y2, and it says I want to have it as a solid black line. So it's gonna be k and solid. Gonna be y2, right? And then it's gonna be 3, y2 to 3, that's right. So it says I want to have it as a blue dot. Okay, blue dot means this, guys. This is blue dot. Okay, and you're gonna have y3. Okay, and this now 4. Okay, it want to have it as solid black again. Solid black. Okay, and y4. So if I run this, I'm gonna have this figure, guys. Okay, so this is very, very now. First of all, the fonts are very fancy because I use the LaTeX as interpreter. Now you have 4 figures and 2 more things. Oh, one of the points I want to show you here. Edit plot. Oh no, I don't want to edit actually. Zoom in. So if I zoom on this, guys, see, this is dotted. Okay, they are dot plotting, but because you think this is solid, but this is dot. Okay, so if I save it, okay, save as, obviously again you have to save as fig, but subplot example I'm replacing with that. I want to show you how it looks like. So, and here we go. This is what we get. So it's very, very neat and clean plotting. Okay, and with the subplot. So we got that. So please do number 3 as homework. Okay, here we go. This. Okay, understand? Okay. Now we have enough tools to eventually go to. Okay, now let us try the following code. So what it is the length of a pendulum, which you will see in ME330, ME430, ME530, ME696, all of the dynamics, robotics, and control courses in San Diego State University. Okay, how? First of all, I'm going to close this. I'm going to open a new file, M-file, and I'm starting to type. Oh, no, I don't have you. New script. Live script was okay. So I'm gonna say, okay, this is the code. So let me first show it. What is pendulum? Okay, guys. New slide. Okay. When you go to the vibration dynamics, robotics, and linear system theory, this kind of the courses. So this is the most famous problem. Even non-linear dynamics course, when you go to grad school, this is pendulum. That's right. You have seen several times. This can be a very simple, a very simple model of your leg when you are walking. When you're standing, even here, okay. If you walk like this with the displacement of the x, your angle of the legs it's gonna change. That's right. So now, so this has a length, guys. And the name of this is the particle pendulum. Particle pendulum. Why? Because when you pass dynamics course ME 220, we assume that the mass of your leg is lumped as a particle at the end of your leg. This is assumption. Okay. So what is particle? And they're gonna teach you in the dynamics. Particle is an object that has zero dimension, has zero negligible dimension, but has mass. Simply means this, but has mass. So I'm saying here M, mass. And this is the length of your leg. So this is a particle pendulum. Okay. So let's go back to the code. We are in the process of developing animation and simulation, because you know the basic commands in MATLAB. So first we have to define L is 0.3 meters. So if I go to the code, okay, you as a professional developer, you have to do this. 0.3. First of all, I said that always do CLC and the clear all. It's going to be useful practice for you. Okay, so this is the length of your leg or the pendulum, and semicolon, and put a comment always as a professional code developer. This is length of a pendulum, exactly what I'm writing here, which you will see in ME 330, ME 530, system modeling and analysis, ME 530, okay, ME 596, which is robotics, ME 696. Okay, now after a while, if I come back to this code, suppose that I'm a naive guy, I don't know what's this, I'm gonna say, oh, this is, I'm solving for this kind of course. Okay, now I taught you about the 4. That's right, 4. I said that you have to generate the series. Theta is between minus pi over 3.1 to pi over 3. What is this? This is physics, guys. Look at here. So when you're standing here and deflecting your leg from this 0, this angle is 0 here, theta. This is theta is 0. If you push to some angle and release it, it's gonna oscillate. That's right. You're gonna learn in dynamics and the vibrations kind of things. I'm skipping the dynamics now. I'm just teaching you the simulation. So I'm saying that I want to model this between pi over 3, 60 degree, and here is minus 60 degree, because this is our datum. Here is plus and minus. So in Matlab, here we go. So theta is between, oh, this is pi over 3, pi over 3, and this is the interval, and pi over 3. And don't forget, when you are in the trigonometry, you have to write your numbers in radians, not in degree. That's a mistake. I'm double emphasizing. You have to do in radians. I'm putting a comment here. You do when you're practicing with me at home. Angles must be calculated in radians, not degree. If you say cosine of, in Matlab, say cosine of 60, it's gonna give you a wrong answer. Okay, don't do that. Don't do that. I'm emphasizing. So here we go. So now for this angle, okay, now this is not even dynamics. This is trigonometry from high school, guys. Okay. So look at here, guys. I'm changing the color. What is this distance with the L and theta? Yes, look at this triangle. If here is theta and here is L, here gonna be how much from trigonometry? L sine theta. And how much is this? L cosine of theta. Okay, but this is what? This is position of this mass, the mass of your leg, because in dynamics you will learn that we are calculating the mass, velocity, and acceleration of a mass, okay, or mass center of the body. So, but in dynamics and other courses, they will teach you that we are calculating respect to a datum, okay, an origin. So here is 0, here is plus, here is plus, this is minus y, this is minus x. I hope that you know this from high school. That's right. So the position of this mass as your leg model, it's in the positive x and negative y. So this is going to be minus L cosine theta, and that's going to be plus. Understand? This is very simple. This is trigonometry. This is not dynamics or whatever. Okay. So if I go into my code, okay. Okay, we got it. So as I did exactly here, you're gonna say x is equal to x of the mass of your leg is L, length of your leg, in sine of theta, and we define here theta here. But for, as I taught you in the for loop, in each iteration puts the new theta here and semicolon because I don't want to see it. And the y is minus, based on trigonometry I taught you, is L what? Cosine of theta. Okay, now we have the position. Now I'm gonna say figure 1. Now you know how to deal with the figure. Now I'm gonna plot this link as your leg in the Matlab. Got here, guys? I'm gonna say, because I taught you previously, that's right, I taught you how to plot a line, a straight line. Go to YouTube links, you will see that. So plot, okay guys, now look at here. Plot x of this point, x of this point. X of this point is always 0. X of this point is how much? We define L sine theta. I'm exactly doing like that. Okay, please do with me, please. So it's gonna be 0 and x, because I define x is L sine theta. I defined here. Its y is how much? Is what the y of this point is 0, y of this point is minus L cosine theta that we defined in the code. That's right. So it's gonna be 0 and minus v0 and y, because y is minus L, that's right. So, and in the code, I said that I want to plot your leg as a blue line, so it's gonna be blue. Okay, now is line width, okay, and 2. I want to say the thickness of the line must be 2. Okay, you can change it to 3, to 0.5, whatever you want. Now I'm gonna say axis. Axis gonna be, I'm putting as minus 0.4, okay, to 0.4. X mean X max, as I taught you in the previous YouTube link. Minus 0.4 to 0, because the maximum of the y is 0, is the origin of, you know that is right. So I'm gonna say, now guys, I'm skipping this line because I want to teach you right now. I'm gonna say grid. I'm gonna skip this command, hold off. I'm gonna tell you why. Oh, there's typo here. Okay, I'm gonna say grid. Okay, title, as I taught you, is title is what? Pendulum motion. End. Okay guys, I developed a code that simulates your leg. Now let us see what happens, guys. First, I'm saving. Yes, I'm saving as leg simulation beginning. We are not there. I'm just started. Okay, save. Okay, it shows me this, guys. Let me close this because this is okay. See, guys, it started to model your leg. See, from minus pi 3 or to pi 3, guys. See, here we go. See, this is your leg. A simplified version of your leg. So now, with the aid of all the commands I taught you until today, you started to make a movie in the Matlab and the simulation. Okay, so let us see what is hold off. Hold off. If I say hold off, okay, nothing happens. That's right, because you, oh, sorry guys, hold off. Okay, it's gonna be the same. That's right, nothing happens. That's right. Okay, now if I say, guys, if I say hold on here in the code, see, let's see what happens. Oh, because it's holding on, so it's gonna plot one by one of the angle of your leg. And the name of this technically is stick diagram. The name of this is a stick diagram. This is good for publishing papers, guys. If you want to see the sequence of the dynamics of the system, this is very useful, guys. Let me increase this to 0.5 to 0.2, and you see the difference between, and you can see the sequence. Look at here, guys, look at here. See, it shows that the dynamics of your leg is evolving, and from minus pi over 3 to plus pi over 3. That's right. So this is a stick diagram. It shows, if you go to technical papers in robotics, you're going to see lots of these things. Okay, so, and now let me show you guys. When I was a master's student, I developed a 14,000 lines code in Matlab. It was a huge course for a simulation of the bipedal robot. If you go to my dynamic systems lab, payman.nm.sdsu and edu, okay, this is my robotic lab. And if you go to the publication, in 2007, I published this paper 13 years ago. This is me when I was a master's at Payman Nasser at Musawi. Okay, so and you see that by a huge code in Matlab, I developed a 3D model of a humanoid bipedal robot that's walking on different faces. It was a huge code in Matlab on that time. So this is the stick diagram, but in 3D case. So now you learn the basic of the stick diagram in the Matlab. Okay, let me close this. Understand? So, but if you wanna present in the conference, you're gonna say hold off, or even don't put nothing. So now what you're gonna get is this. That's right. Here we go. Now I'm gonna teach you how to save this as a movie, as an AVI file, or as an MPEG file. Okay, MPEG 4. Okay. So we just learned how to deal with these things. So in the next class, I'm gonna teach. So see, make the following animation. Please do practice 21 at home. Please do that. This one. See, a red dashed circle with the radius of 2 cm moves from 0 and 0 to 5 and 5. X is between this and Y is this. Okay, understand? And so try this, and I'm gonna solve this on the next class or on Monday, because this is very important. Make a simulation that the radius is rolling from 0, 0 to 5 and 5. And then I will teach you the fill command in Matlab, fill 3, because we're gonna use it. See, fill 3, because we're gonna use it in the simulation of ODEs. Okay, thanks guys.